So let's say you run a large facility, a hospital, a campus, maybe a major hotel. You probably have this one monumental headache.
Oh, I know the one.
How do you deliver hundreds of TV channels when, half your sources are these 20-year-old analog feeds and the other half is pure modern IP streaming?
That is the exact problem we're digging into today. And the solution, surprisingly, is a single piece of hardware. The Thor Broadcast H-24AV-QAM-IP high-density encoder modulator.
That's a mouthful.
It is, but what it does is brilliant. It's this robust, single 1RU system designed to be an entire distribution hub, a whole headend in a tiny little bit of rack space.
Wait, so this one box is the ultimate video translator.
You could call it that.
So the real aha moment here is that this device is built to merge completely different video eras. It takes those ancient analog signals, combines them with cutting-edge IP streams, and then just broadcasts it all out.
And broadcasts it all out simultaneously to both traditional cable and modern network streams.
Okay, let's dive into that, the analog side first. This thing is built for density, right? Up to 24 AVV CVBS inputs.
Right, and CVBS is that old school composite analog video, the yellow, red, and white plugs.
24 of them. I mean, I have to ask, is that really necessary today? Doesn't everyone just use HDMI or IP?
You'd be surprised. Legacy infrastructure is incredibly expensive to replace. Many places still have critical systems like security cameras or internal info channels that only output CVBS.
Okay.
But the real value isn't just taking the signal, it's cleaning it up. The unit converts that analog data using MPEG-2 encoding and runs it through something called advanced pretreatment.
Advanced pretreatment. That sounds like a spa day for video signals. What does it actually do?
It's crucial. We're talking about deinterlacing and noise reduction. Analog signals get noisy and flickery, you know?
Oh, yeah.
This processor scrubs that old video, so when it comes out digitally, it looks fluid and professional, not like a dusty VHS tape. The audio gets a similar treatment, converted to standard MPEG-1 or AC3. Okay, so that's the analog side, but now let's talk about the digital capacity, which is, well, it's just insane.
Go on.
Simultaneously with those 24 analog feeds, the unit can pull in up to 128 STPS streams over the network.
And STPS is just a standard single video feed coming in over IP using common protocols like UDP and RTP.
Exactly.
So hold on. We have 24 aging analog feeds and 128 network streams, all feeding into one little chassis. Whoa! That's over 150 potential sources. How on earth does that pile of data get organized into a clean TV menu for a guest?
That's the magic of the multiplexing function. It merges all 152 sources into one cohesive channel lineup. And a really vital technical part of this is PID remapping.
Okay, that's a great technical term, but let's put on our IT manager hat. What's a PID and why does remapping it matter?
Think of PIDs as tiny digital address labels. They're attached to every little piece of the stream, the video, the audio, the subtitles.
Right.
The remapping is basically an automated traffic controller that makes sure none of those little labels from 152 different sources get mixed up. It prevents signal corruption and chaos.
Which brings us to the output, where the flexibility really shines.
It does. You get two paths out. First, you get 4 robust RF outputs. These use DVB-C or DVB-T standards, which is how you send signals over traditional copper cable.
And the sources mentioned modulation standards, things like 16, 32, all the way up to 256 QAM. Why should anyone care about those numbers?
Those numbers represent signal density. The higher the QAM number, the more data you can squeeze onto your existing cable.
So using 256 QAM means you can pack way more channels onto the network you already paid for.
Precisely. Maximizing efficiency. And second, you also get 4 MPTS or multi-program IP outputs for modern network streaming.
So tying this all back to our listener, this is the device that lets a hospital, for example, become its own private cable provider. They control exactly what content goes to every single room.
And that control goes even further, right down to branding. A crucial feature for these businesses is the support for QR code, logo, and on-screen display insertion.
So a hotel can put its logo on every channel.
A hotel can digitally stamp its logo, or a hospital can instantly push an emergency alert across every single channel it broadcasts. It's total control.
That really is the breakthrough concept then. It's the lowest cost per channel solution for combining everything from your oldest security camera to a 4K IP stream into one customizable broadcast bridge. It's what keeps these massive, complex facilities running affordably.
So here's a thought to leave you with. If this system allows for fully customized digital channel lineups, logo insertion, and complete content control, Just consider what level of hyper-localized content and personalized communication becomes possible when any large facility can effectively and affordably become its own closed network microbroadcaster.